Right. The heuristic values, you had to go from the scenario, and it had to be based on the scenario. It was about airports, wasn't it? So those numbers could represent time, minutes. It could represent fuel, couldn't it? So it doesn't have to be a physical distance. It can be other things. So it could be actual amount of fuel burnt between airports. Okay? Anything that was sensible was okay. Right. So the next bit, purpose of the heuristic. Now, there is only one purpose of the heuristic. Okay? There were some quite gobbledygook answers on this, but I think a couple got it right. Right. The whole point, it's the heuristic that separates A star from Dijkstra, isn't it? Dijkstra's agnostic, doesn't even know where the goal is. He just like trips over it and goes, hey, found the goal. But I've got the best route. Always gets the best route. A star does what? What's it use the heuristic to do?
Gain more information.
Nope. Speed it up. Speed the search. That's the whole point. That's why A star can beat Dijkstra. Because it speeds up the process. The whole purpose of having the heuristic is to guide that choice of node. So that we take a node that's more likely to be closer to the goal. To speed up the process. That's what it's for. If the heuristic's no good, it can make it slower. And you can get an unoptimal route. Remember, Dijkstra is always guaranteed optimal route. Always, because it's agnostic. But the heuristic in A star can give you a false direction. Which can actually be useful if you want jaggedy routes for things. Or you're trying to use A star to do some sort of pattern. You can use it for all sorts of weird things. You don't have to do it to find a route somewhere. You could make it for doing geometry and things. Right, okay, so that was by the by. Right, then we've got to do A star on this. Now it said, I don't know why a few of you messed this up. Right, so the question was, and I can work it out. The goal is E. How can I tell the goal is E?
Heuristic is 0.
Yeah, because the heuristic estimate for the distance to the goal is 0, which means that must be the goal. Right, where we start, we've got to read the question. So I think that was on the next page. He said H. Okay, so we're going to start at H. Now, I was pretty annoyed when this question came up because of the numbers. They're hideous. Okay. But you've just got to take time, make sure you double check things. Right. It's A star. So we've got to make sure, and I'm going to start off by just writing all the nodes names down. It doesn't matter what order I do them. So I'm just going to go H, N, G, L, M, and E. Remember, we've got a few bits of information. We've got the cost, so we've got the G. So I'm going to put G first. Then I'm going to put, and that G could change. Okay, so I'm going to leave a little bit of space, and I'm going to put the H cost. That's going to be fixed, so I can write that down. So, and then I'm going to do F. And just as a, remember that's full cost. That's the one we look at to decide who goes, we pick next. If you just do that, that's your little, that's what you're working out. So just to remind yourself, we need to keep track of the parent, and we can start the table by putting all the heuristics in. So we've got H was 80. So remember, that's an estimate of the relationship between H and the goal. Okay. N was 90. So that's according to the heuristic further away. Whatever these numbers represent. 70 for G. 50 for L. M was 20, so that's quite close. And then obviously E is 0. Right, we're going to start at H. So we're going to set the parent to that to be null. What's the cost from the start node? 0. We haven't travelled, have we? So we can put that in, which means we can calculate our F straight away. So the F is 80 for that. Right, it's really important, because when you look at the mark schemes, they've got things down in a certain order, even though this mark scheme goes a bit off-piste, wrong. But it's really important that you show the order you pick. So put a 1. You don't need to do a cross to say it's in the closed set, because the fact that you put a number next to it means you've selected that node. Right, so we're at H. So what we do is we look at our neighbours and we calculate how much it's going to cost us to get to our neighbours. So we look at our travel cost and we add that onto the travel cost. So let's have a look at the first one, N. So N is 210 from H. So if we add 0 to that, we still get 210. But the full cost is 210 plus the heuristic. So that gives us an F cost of 300. So the parent for that costing is H, because that's where we're currently at. If you've forgotten, look at the last number you wrote down. So I can see that the last number I wrote down was 1 next to H. Right, the other neighbour is G. So G is 25 from H. It hasn't cost us anything so far, so the cost to get to G should be 25. But the full cost is 25 plus 70. Which even those numbers, it's like, oh, I could easily mess this up. So that, be careful about it. That gives me a full cost of 95. My parent is H. Right, that's the end of that iteration of the A star algorithm. What we do now is we look for the ones that are open. So anything that is still there. So we've got 395. We can't pick H again because it's in the closed set. It's been visited. We don't visit twice. Otherwise you go around in circles. Right, so we look for the lowest F cost. So it's going to be G. Gets explored next. So I'll write number 2. Right, okay. We look at the neighbours. It's got 3 neighbours. H is in the closed set, so we don't look at that at all. But we have got a neighbour L. Now this is where the numbers start getting a bit. Right, L is 51 away from G. It cost us 25 to get to G. So we've got to add 25 and 50, which is 71.
6.
See how easy it is to cock up?
Exactly what I did.
Did you know what you put?
No, I did it later on.
Yeah, you did one later on, yeah. Which was a big one. Yeah, so 25 and 51 is 76. The full cost of that, we've now got to add 50 on, so that's, I think, 126.
Yeah.
But you've got no calculators, it's not fair, I know. Right, the parent for that costing was G. Right, M, with a more hideous number. Right, it's cost me 25 to get to G. It's going to cost me another 176 to get to M. So 176 plus 25 must be 201.
That's where I'm at.
Must be 200. But the full cost is 201 plus that heuristic. So that's 221. And remember, it's the F that we're looking at. Right, so that was parent G. End of that iteration of the A star. So we can see we've visited 2 nodes. We've got 3 that are in the open set. E hasn't even come into the picture yet. Right, so we're going to look at the F and we can see N is 300, L is 126 and M is 221. So we're going to pick the lowest, which is L. So L becomes our third pick. Right, so we look at L. There's a neighbour G, but G's in the closed set. The only other neighbour is E. Now, we're only looking at it as a neighbour. We have not visited yet, so we do not say we've found the goal. That's how you can go wrong with these algorithms. We do not do it until we pick it. So all we're going to do is do a calculation of the cost. So, to get to L, we have got 76 so far in our costing. It's a further 307 to get to E. So 307, so I'm going to do it in bits. So I've got 377 plus 6. Which, no, 383, isn't it? Yeah, 383. Luckily, we don't have anything else to add on because the heuristic says 0. So we write 383. But we need to make sure we've said parent L. So we've visited 3 nodes. We've looked at all the neighbours that are in the graph now. But we're going to go again looking for the smallest F cost. So we've got still open, we've got 300, a 221 and a 383. So we're going to pick M. Okay, M. It's got 3 neighbours. G's close, so we just ignore that. But it has got a neighbour N and it has got a neighbour E. So let's have a look at E first. So it cost me 201 to get to M. It cost me another 185 to get to E. So that will be 386?
Yes.
Right. That is not quicker, not cheaper than our current costing to E. So we don't change anything. Okay. Let's have a look at N. Now we can physically see N's in the wrong direction, but the computer can't see that. We're looking at one node at a time. Right. N. It costs 201 to get to M. It's going to cost me another 233 to get to N. The heuristics are a bit weird, but anyway. Right, so 233, so that's going to be roughly 400 and something. That is not a better cost than what we currently got. So we don't update. Okay, right. So we finished that iteration. We did a few work it out. We didn't update anything. So it didn't get us anywhere nearer, but it showed there wasn't worth going down those routes. So we got 2 open ones. We got a 300 and a 383. We've got to pick the N. We can't suddenly have knowledge, so we have to pick N. Right, N has got 2 neighbours. They're both in the closed set, so there's literally nothing to do. M's gone, H is gone. Right, our final pick is the goal. So we stop. And then we have to write our route. So our route is going to be, and I always write it backwards, so I go from E. Where did I go? Look at my parent, L. L, where was L's parent? That was G. What was G's parent? H. What was H's parent? Nowhere. No parent, it's null. That is my route. The numbers were minging on that. And I think when I first looked at it, I clocked it up a few times. You know, a few years ago now, but the numbers aren't very nice. And they tried to make them quite close, especially that M to E one, didn't they? And it's like nearly like it's deliberately trying to catch you out if you just added up 2 numbers wrong. So I don't know why they did that, but they did. Any more questions on that? Try and stick to this, G, H, F. But you must do this bit with the numbers. You must show the order you visited. And it's also for you, so you can go back and double check yourself. Right, I'll stop that one.